How you doing, everybody? My name is Matt Brown. I'm a solutions architect here at Endor Labs. And in this video, this part of the series of building a software development lifecycle, how open source kind of implements throughout, this is the design portion of that. So we've covered the planning session, we've covered the requirements section. This is right after requirements. So we've gone ahead, we've collected any requirements from the stakeholders, from the business, from clients, whatever have you. Now we're going to take those requirements, take all that planning, and we're really going to build a blueprint and get all of this down on paper. Typically, this is done through something like a software design document where you talk about everything and essentially lay out and draw a blueprint for this application, for this project you're working on. And there's three major things to think about. It's the technological, the practical, and the financial. So things, we'll cover all of this, but the technological things like a programming language, the architecture, like how does this like work actually? How are things talking to each other? The practicality, are we going to be designing some weird API that only works in a certain way with a certain version, choosing some programming language that only 10 people know about in the world, something a little crazy like that. We want to make this practical. And the financial portion of it, we always have to think about cost. We may want the coolest thing and we may want to build it a crazy way, but is it going to be cost effective, and are we actually going to be providing value to the business by implementing it? Those are the three biggest things to think about during the design: is the technological, the practical, and the financial. We'll talk about a design approach decision, deciding on architecture and kind of methodologies, programming languages, how it actually integrates, like how open source integrates through all of this, where and how to actually use it in the design. Some stakeholder review. You don't just want to say, okay, yep, looks good, done. We want to have iterative feedback, making sure we're aligning with everything, especially with the stakeholder, and kind of what this all means, right? We're going to make everything we've learned in the previous couple of steps into this blueprint, into this design. So specifically, what are we talking about in this software design document? This is a very common thing. So it's going to be things like, okay, what's the architecture like? What are the different interfaces like? Are we going to be using microservices, or are we going to be having a whole monorepo where we just keep everything? How about containers? Should we use that? What kind of Kubernetes should we use if we use containers? Should it just be open source standard Kubernetes, or should we go with a more enterprise provider? Your tech stack throughout. Let's say you're going to just go straight to cloud. Are we going to use Terraform? Are we going to use Ansible? Are we going to use something else? There's a ton of questions to ask throughout the design phase and a ton of detail to get down. And if you just Google software design document example, you'll be able to find a ton of different examples of what they should include. What's the user interface going to use? How is it going to be deployed? How is it going to be managed? It sounds really simple. It really does just sound like a blueprint, but that's exactly what it should be, right? And we can share a couple of examples of what a standard kind of software design document looks like. That's something that we can actually share. So what's the role of the design? Why even have a design in the SDLC? So we have to verify the software requirements in here. So you may have gotten some requirements from the client or from the business saying, hey, we want this, we require this and that. During the design phase, it may come to realization like, oh, this actually isn't feasible, or this is going to be super expensive if we do it this way, or this programming language doesn't actually jive well with this kind of package manager that we use, or we want to deploy this way. We have to think about how the programming languages may affect that because of whatever reason. So throughout this, you may find some things in the requirements, not may, you definitely will find some things you may have gathered in requirements that you now need to revisit to go back to the client with the customer with this software design document to say, okay, hey, we got your requirements. We can meet most of them. Here are some considerations that we'll swap out instead, so on and so forth, right? And of course, you really want to choose the best design approach for suitable programming languages. This is the practicality portion of it. And you do want that stakeholder review and kind of that iterative feedback, right? Involve them. Say, hey, this is what we're thinking. What do you think about this? We're trying to change that, so on and so forth. This is your blueprint of how you're going to actually build this application. Great. What does open source matter in this, right? Why even consider open source for here? There's a lot of things that you could just simply pay for and be done with it. Obviously, that's in that financial aspect. So maybe you want to do some open source, right? You should still contribute to those open source maintainers. Highly recommend that. Will it be as expensive as some kind of enterprise software? No, people should still contribute to open source maintainers. So some things you want to think about when implementing open source, right? The architectural consideration. For these languages, do they have good package managers? Or should I use some kind of different package manager, like maybe like Bazel or something like that, to manage and build out all these applications with the open source dependencies? What are some of the challenges for some of these package managers and languages with open source that I need to keep in consideration, right? Like Python, you can really get yourself down a rabbit hole of certain dependencies not supporting certain versions of Python and other dependencies. It could be really confusing and really complicated. Things you want to keep in mind, what are the kind of challenges and what are some best practice for interfacing libraries with the core code, package managers, you build tools, things like that. The other kind of big thing to think about is, okay, we've picked these, right? But I want to have some feedback, some fallbacks and alternatives, right? So if this dependency doesn't end up working, or we have a lot of challenges with this kind of dependency, or we have this category of we're going to have an open source tool that does this, and you go ahead and try to discover those, you want to have some kind of fallback to some options to really figure out, okay, what can we use? What can we not use? In case something bad happens where we find out this actually doesn't work, what can we fall back on? And that's really important to find certain dependencies, their quality, their how active they are, how popular they are, to say, okay, yeah, this is a good dependency to use, or maybe we should pick a different one. So a really good thing to do is prepare a couple fallback options just in case the number one doesn't work out. The main thing I would say is the language and package manager compatibility, right? If you're going to pick a language and you want to use a lot of open source with that language, pick one that has a good package manager that obviously has a lot of contributors. There are very language specific package management. There's NPM for Java, there's pip for Python, Maven, or NPM for JavaScript, I'm sorry, pip for Python, Maven for Java. There are challenges with each one. No package manager is perfect. And there's a lot of things that go on during the build. We'll talk about that in a later step. You want to have a package manager's or a package manager that you can easily work with, that's well known, that when it does run into these kind of situations, has a good way to remediate that or guide you through. Python, while it does have a lot of issues with mismatching versions and things like that, it will tell you that. It will explicitly state a lot of this information. So will the other languages too. Maybe you want to have a package manager and build tool and you're writing Android applications using a lot of Kotlin. Gradle is a great choice for that. And a lot of development teams love Gradle because it's pretty much its own language almost, like it uses Groovy or Kotlin, right? But it's super flexible for developers to actually do what they want during the build process, which is really nice. So a lot of things like that, depending on the language you pick, depending on how you want to deploy, how you want to manage, these are all the different things that you want to think about. So why is design important? You're making that blueprint and you're paying special attention to all these different considerations. And when it comes to open source, what do you actually want to include? How you're going to include it, all of that. And really, the thing I want to really emphasize is a well thought out design that includes the technological items, the practicality of it all, and the financial implications of it all. Something that's well thought out, that has all three of those things in mind throughout, that is like super important. That's super important. Because if you get it right or do your best to get it right in the beginning, the rest of the dominoes fall. The dominoes will all fall into place. Is it going to be perfect? No, nothing in life is perfect, right? But to just really keep those considerations in mind, keep the requirements of the customer, client, or business in mind, but having that ability to effectively communicate when things change and when things need to get updated or swapped out, something like that, that is super duper important. And when it comes to open source, just think about the potential pitfalls, have a backup plan. Dependencies can get complicated. Open source dependencies can get super, super complicated. And as long as you think about this stuff during the design phase, you'll avoid all those complications in those situations later, for the most part. Thank you very much for attending. Appreciate it. And we will see you in the next one. Take care.